So problem number 8 of the MIT integration B qualifying exam standard 12 is the definite integral from x equals to 0 to x equals to pi over 2 or 1 over 1 plus sine x. So it's an interesting problem. Let's see how we may be able to solve it. Is the definite integral from x equals to 0 to x equals to pi over 2 or 1 over 1 plus sine x. Right? So the rule of thumb for such problems is substitution, and we do say let t be equal to tan x over 2, such that dt dx is equal to a half sec squared x over 2, such that dt twice dt over sec x over 2 is equal to dx, and this is 1 plus t. This is 1 plus tangent squared x, which is 2 dt over 1 plus t squared is equal to dx. And this here is important substitution. Now we've got to express this into the half angle formalism. So this is the same as 0 to pi over 2 or 1 over 1 plus 2 sine x over 2 cosine x over 2. Now, how to derive cosine x over 2 or sine x over 2? We use a triangle, and we know that if we have a right angle triangle and the base angle is x over 2, the tangent of this angle is the opposite. So if tangent x over 2 is t, this is opposite t over 1, the adjacent, and the hypotenuse becomes 1 plus t squared using Pythagoras theorem, such that the sine of this angle x over 2 is the opposite over the hypotenuse. So sine x over 2 is equals to t over square root of 1 plus t squared, and cosine x over 2 is equals to adjacent, which is 1 over square root of 1 plus t squared. Right, so now we have a way to express this sine x and cosine x in form of t. The next thing is we need to be able to transform the limits from the x domain to the t domain. So since we said t is equal to tangent of x over 2, and you have x here and t here, when x is 0, tangent of 0 is going to be 0, and then tangent of x over 2 is equal to 0. When x equals to pi over 2, tangent of pi over 2 over 2 is pi over 4, tangent of pi over 4 is going to be 1. Right? Therefore, our integral from x equals to 0 to x equals to pi over 2 of 1 over 1 plus 2 sine x over 2 cosine x over 2 is equal to the integral from t equals to 0 to t equals to 1 of 1 over 1 plus 2 sine is t over square root of 1 plus t squared. Cosine x over 2 is 1 over square root of 1 plus t squared, and dx is the same as 1 plus 2 dt 1 plus over 1 plus t squared. Since we had our integral being to 1 over 1 plus 2 t over square root of 1 plus t squared, 1 over square root of 1 t squared, 2 dt over 1 plus t squared. This becomes integral from 0 to 1 of 1 over 1 plus 2t over 1 plus t squared, 2 dt 1 plus t squared. So we can multiply both the numerator and denominator with 1 plus t squared, and this becomes 0 to 1 of 1 over 1 plus t squared over 1 plus t squared plus 2t 2 dt 1 plus t squared, and that would cancel. We can pull the t out, the 2 out this side, and this becomes 2 the integral dt over 1 plus t squared plus 2t, which is the same as t over 1 plus t squared. Now we forgot to include our limits there. So this becomes negative 1 over 1 plus t. There's obviously a 2 there, 0 to 1, which means that we have negative 2 a half when t equals to 1 becomes a half, minus when t equals to 0, 1, which is equals to negative a half times negative 2 times negative a half, which becomes 1. And ladies and gentlemen, that is our answer. Okay, thank you so much. You enjoyed following along. Until next time, à tout à l'heure, à la prochaine fois.